Welcome to this session, and today we'll be taking a look at some few questions on loops, functions, and arrays and get to understand what they actually mean. Alright, so let's dive right into it. So we start with loops, right? First question says, which loop structure is guaranteed to execute its body at least once, even if the condition is false from the start? Right, then we have while loop, for loop, do while loop, none of the above. The answer right here is the do while loop, right, which is a post-test loop. So it actually executes the statement first before it checks for the condition, right? So this is a very simple one. And second question, it says, look at the following code snippet. How many times will hello print, right? So this is using a for loop, and we have our initialization starting from 0, and then the expression being less than 5 with I plus plus. How many times is the hello going to be printed? Right, so this iteration is starting from 0 and ending at 4. So if we are to count from 0 up to 4, we are going to end up with 5 numbers, right? So we can have 0, 1, 2, 3, 4. All right, so this particular statement, which is the hello, is going to be printed 5 times, right? Starting from 0 to 4. Right, so let's go to 3. What is a major risk of a while loop if the condition variable is never updated inside the loop body? All right, so what does this actually mean? Let's dive into our code blocks and get to understand what this question actually means, right? So let's do this. Let's declare a variable I and say it's equal to 1. Then we say while our I is less than 5, we can see out I, right? And then give some space, right? But you realize that with the while loop, you always need a counter to be incrementing your condition variable, right? So we don't just end here. We normally do something like I plus plus, which will increment our value after each iteration, right? So what this question is asking us is, what if we don't bring this thing? What will happen if we don't bring it? What will happen if we don't bring this? And we expect an infinite loop, right? Yes, so let's end this. And if we are to have this here, it's going to be incrementing our I, and it will eventually get to 5 and break out of this loop, right? So that is it about this particular question. So our answer is going to be an infinite loop. All right, so let's go to 4. We have, which loop is generally best suited for situations where you know the exact number of iterations before entering the loop, and this right here is simply the for loop. Let's go to 5. Then we have, what will be the output of the code block? So we have int count equals 10 while the count is less than 5. Print out count and count plus plus. All right, so what will be the output here? Count has been assigned a value of 10, which is not less than. All right, so this is actually going to be false, and so we cannot enter the loop statement, right? So our answer right here will be, it will print nothing. We can try this simple code. You can run this. Yeah, and this should work. All right, nothing is going to be printed on our screen. All right, so we get nothing because 10 is not less than 5, right? So let's go ahead to 6. So we have what will be the output of this do while loop. So it's the same concept, but this time around it's using a do while loop. And you know, a do while loop is a post-test loop, right? So even if the condition is false, we get a statement first before we check for the condition, right? So this is actually going to print out the value of x, which is 10, and increment it by 1. So by the time it even checks here, it's going to check is 11 less than 5, right? Which is no. So the output we expect to see here is 10, right? We can try this and see how it's going to work. All right, so let's run this and we expect to see 10 printed, right? So let's go to the next question we have. Which keyword can be used to immediately terminate a loop and jump to the code directly following the code? So this right here is going to be our break keyword, right? So what is this actually doing? Let's simply create one for loop. So let's do for int I equals 1 and I is less than 11, then I plus plus. So let's say we want to output the numbers from 1 to 10, right? So we can just do cout I, we can give a space here, and then we are going to get 1 to 10, right? But let's see, even though our ending range is less than 11, right? So let's see, when we get to 5, we want to break out of this loop and not continue, go to the next line of code, right? So let's actually put something here like outside the for loop. So I'm going to take this and then let's say if our I is equal to 5, right? Then we can break out of this particular loop. Or let's say we should instead use if I is not equal to 5, right? If I is not equal to 5, we are going to print out the value. All right, else that means if it is 5, we are going to break out of this for loop. All right, and then we'll print what we have here outside the, we are outside the for loop. So let's add an end line here. All right, then we expect that when we get to 5, our code is going to check this, and because this is 5, it will go to our else statement and break out of this code, right? Yeah, so let's run this and we expect to see 1, 2, 3, 4. But when it gets to 5, it will go, and when it gets to 5, it will go to the else statement and then break out. So it won't continue from 6, 7, 8. It breaks out of this loop and then it goes to the next statement outside the for loop, right? So we can end this and continue with our questions. Right, then we have what is the correct order of the three components inside a standard for loop. All right, so with a for loop, we need initialization, a condition, and an update. Right, so our answer here is going to be C. Then we can have what does the continue keyword do when encountered inside a loop? All right, so we have the break keyword and then the continue. So instead of doing break, we can do continue, and this is going to skip that particular number. All right, so instead of breaking out of this loop when we get to 5, we want to skip that 5 number, right? And then we can continue with whatever is in the range. So let's output this and we expect to see all our numbers except 5, right? So we see 1, 2, 3, 4, then it jumps. All right, it skips 5 and then it prints the next numbers on the line. But then for break, it's going to automatically break out of the loop even if the loop hasn't ended, right? Yes, so that is what this question is about. And what do we have again? So what will be the answer? It skips the rest of the current iteration and jump directly to the next condition evaluation or update. Right, so let's look at the last question where we have what is the main structural difference between a while loop and a do while loop. And this is simply going to be a while loop checks its condition at the entry point. So simply a while loop is a pre-test loop and a do while loop is a post-test loop, right? Now let's dive into our functions. All right, now let's start with our functions and see what we have on functions. So our first question here is, what is a function prototype? And function prototypes are the headers we place before our main function, right? So from our previous lessons, we did have some function prototypes here. All right, so these things right here are going to be our function prototypes. You realize we have some headers here, but there are no function definitions here, right? So these are our function prototype, and the actual definition is they are under the main function, right? So the definition for the first function sum is here, and then for the second one, the menu function is right here. So these are what we call prototypes of functions, right? Or function declaration. So what is a function prototype again? And the answer right here is going to be B, right? A declaration that tells the compiler the function's name, the return type, and parameter before it is used, right? So the function name is going to be this, the return type is going to be this, and then the parameters are this right here. Okay, let's go to the next one. So we have which keyword is used when a function does not return any value to the caller, and that is simply going to be the void keyword, right? Then we have, look at the following code. What will be the output? We have void update value int x. Then we are actually increasing this by 10. So what will be the output? We say num equals 5, then we call num, we pass num as the value to our function. Then we see out num. Right, so this right here can be a bit confusing because in our lesson on functions, we didn't talk about passing a value by reference and passing a value by value. All right, so when passing something to a function, you can pass it by reference, which will be the actual memory address in the storage, right? And then you can pass it by value, which will be a copy, right? And this right here is actually the normal passing of a function of a parameter, which is by value, right? So we are going to have a copy of this num here, and this is going to be incremented to 10, right? But then we output this, and then this is going to pick what is actually in memory inside our main function, right? So we still expect to see 5 instead of 15. All right, but then instead, if we should have passed this by reference, which is done by using this, right? Your data type, then you bring your ampersand. This is by reference. This is going to tell our function the actual location of our non-variable, and by doing 5 plus 10, it would have updated what was inside the storage, right? So this right here can be a bit tricky if you are a beginner in programming, right? So let's get to this. It says, what is the purpose of the return statement in a value returning function? And this right here is going to be b, which is saying it sends a specific value back to the line of code that's called the function. So let's see if we have an example here. Function that, so our sum function is returning an int value, and then we did call it for our variable result. So this value is going to be passed to our variable. All right, so we did the function call here, and the value will be stored inside our result variable. So what do we have next? Let's go to 5. Says, which of the following is a valid function prototype for a function named multiply that takes 2 integers and return a double? It takes 2 integers and returns a double. As far as it is returning a double, we want to make sure we have the return type being a double, right? It's a function named this, and this is a function prototype. So we can have a and a b here to make this actually complete, right? So let's come to 6, and it says, what is a parameter in a function? So parameters are basically what we pass inside the bracket here, right? These things are our parameters. So this right here is going to be b, a variable declared in a function definition that acts as a placeholder for incoming data. Then we have 7. If a function is defined above the int main function, is a function prototype strictly required? So what this question is asking, if you define the function here, so let's check our other function codes. All right, these are all function definitions, right? So if we do this, do we actually need a function prototype? Something like this alone, having these things here. All right, this will be the function prototype of this, and the answer is no. If you do the function definition before your int main, there is no need to do a function prototype. You only do the prototype if you did your function definition beneath the main function, like what we have here. All right, so we have the function prototypes here, and the definitions are at the bottom of the main function. Then what do we have again? We have what is wrong with the following function definition. All right, calculate area. We are taking weight and height and saving this. All right, so this is actually going to be an error for the return type, right? We know while this is not void, we expect a return, right? But then this is actually not returning anything. So our answer is going to be, it promises to return an int, but it's missing a return statement right here. Then we have which line correctly calls a function that returns a string. All right. So if the function is returning a string, we expect to have it inside a string variable, right? And so this is actually a simple function call which is being passed to a string variable. So our answer right here is going to be A. All right, so let's dive into our array sample questions and we can get to learn some few things from here. So one, we have what is the index number of the very first element in a C++ array. All right, and this, if you've learned arrays, you should know that the index of the first element in an array is 0. It's always going to be 0, right? Then we have 2. Which of the following correctly declares a standard array of 10 integers, right? So with arrays, what we need is the data type, the array name, then a square braces, which will take in the size of the array. So this right here is simply going to be B. Then we have 3. What happens if you try to assign a value to numbers 5? So let's say we are trying to, all right, then 3. All right, so 3, we have what happens if you try to assign a value to numbers 5 in an array declared as int nums5, right? Numbers 5. So this is actually an array that is going to take in 5 items, right? And with 5 items, we expect to have the index of the array ending at 4, right? So let's try this quickly and see what we can understand from this side. Let's take this away. Then let's declare an array. Say numbers, then we do 5, right? So if we are to assign a variable, if we are to assign some items to this array, we are probably going to have something like 1, 2, 3, 4, and 5, right? And then the index we expect to be 0, 1, 2, 3, and then 4, right? When you try to go beyond that, this is outside the storage for our arrays, right? So this is what this question is asking us, that if we try to make use of numbers 5, all right, what happens if you try to assign a value to this, right? And this right here is, we have out of bounds memory error, right? Because our array should have 4. I mean, the highest index should be 4, right? Yes. So let's move on to question 4. So you have, look at this declaration. You have double rate, and we did not specify anything, but then we have 3 items here, right? 1.2, 3.4, then 5.6. So what is the size of this array? All right, so the size of this array is going to be 3, all right, because C++ implicitly counts the initialized items, right? So this is a very simple one, but can be tricky. All right, then we have 5, which loop is perfectly suited to print out every item of an array when you know the exact size, and this is simply the for loop. So let's go to 6. If you declare a standard local array like int items with a size of 100 inside the main function but do not initialize it, what data does it contain? All right, this is a very interesting question. Let's actually try this and see. So let's say we do 100, and we can try using a for loop. Say int I equals 0, and then I is less than 101. Then we can do I plus plus, and then the printing out the contents of the array. All right, if we wanted to assign values, we could have done equal to this and then put some values in there, right? But we did not do that. So what do we expect to see down here? So let's actually add some separate. Let's add some space here. Okay, so let's try running this and see what we are going to get. A for loop. All right, so we have to end this with a semicolon, and let's run this again. And then we are definitely getting some gibberish, right? So let's get back to our question, and then what will be the best answer? So it's going to be C. It contains unpredictable garbage values left over in memory, right? Then let's go to 7. Can a standard C++ array change its total size while the program is currently running? So the answer is definitely going to be no, right? But we have two nodes here, so which of them? And this is going to be B, which says no, standard arrays are strictly fixed in size once created, right? So if you give your function a size, that is what will be used, right? So you can't try to increase the size while your program is running. If you try to do that, you automatically have out of bounds error, right? And let's go to 8. It says, what is the index of the last element in an array of size n, right? An array of size n, and this we expect our answer to be n minus 1. Let's actually try to understand it from here. So let's do 5 here equals to 1, 2, 3, 4, 5. Okay, so with the index, we say we start from 0, then we go to 1, then we go to 2, then we go to 3, then we go to 4, right? So the index of the last item is always going to be 1 less than the position of the item, right? So this is on the fifth. This is the fifth item. So we do 5 minus 1, right? 1 less than the position of the item. Then we can get our answer to be simply n minus 1. Then let's look at this. So we have what statement about arrays is true. And we are not going to waste time here. We are going to select the answer straight away, which is C. An array stores elements of the same data type in a contiguous side-by-side block of memory, right? So with arrays, let's do a comment here. And let's say in memory we have this, right? So let's assume this is our memory. So when you declare an array, all right, and then you can call it you can give it a data type of int with a size, it gets a contiguous size in memory, right? And all these things are going to be together specifically for the array, right? So you can have the items of the array where one is going to be saved here, like you have A here, and the next item is going to be saved somewhere here, right? That is not done in arrays. Everything is in order, all right? They are stored continuously in the specified memory, right? So let's go to the last question, and it says, what is the error in the following code block, right? So let's look at this again. We have an integer array which should contain 3 items. So we have 10, 20, 30. Then we are trying to print this, right? But while printing this, while if we are to include this, the equal to sign, it is going to do 0, index 0 for this, index 1 for this, index 2 for this, and index 3, which we do not have anything for index 3, right? It goes beyond the boundaries of our array. So our answer right here is simply going to be A. The loop condition I is less than or equal to 3 will cause it to check values for index 3, which is out of bounds, right? So thank you very much for your time. This will be it for this video. I hope you've learned something great out of it, right? Make sure to hit the like button, subscribe, and I'll see you